Hello everyone, today we are going to be talking about proportions. So there's three parts to this video. The first part is solving proportions, the second part is word problems that are associated with proportions, and the third one is conversions like inches to centimeters using proportions. So go ahead and look at the description, look for those timestamps if you're looking for a specific skill. So here we go, let's dive in. So we solve proportions using something called cross multiplication, which we also sometimes call the butterfly method. We call it the butterfly method, as you can see, because it can look like a pretty little butterfly when we draw it out. So cross multiplication means that we are going to take that proportion, which remember is those two fractions that are set up equal to each other, and we are going to multiply those diagonals. So we're going to take the x times 14 on one side, always an equal sign in the middle, and then the 6 times 35 on the other side. We simplify those by getting 14x and 210. And then we just have a one-step equation to solve. So we divide both sides by 14 and we get x equals 15. So let's go ahead and practice some of those before we get into the word problem. So how do we solve proportions? We're going to do that butterfly method. So I'm going to take that y times 18 and 6 times 9. So we've got 18y on one side, 6 times 9 on the other. So 18y is going to be equal to 54, and when I divide both sides by 18, I get y equals 3. So simple as that. That is how we are going to solve a proportion. Go ahead and pause the video here and try number 2 on your own. Okay, let's see how you did. So we have our 44x on one side, our 8 times 33 on the other. We get that 8 times 33 gives us 264, and dividing by 44 on both sides, we get x equals 6. Now, as you'll notice, there's kind of some patterns into how this happens. So here's kind of a shortcut that we talk about with my students. You notice that there's always going to be one number diagonal with our variable or our letter, and there's always going to be two numbers that are diagonal together. So if you always look for those two numbers that are diagonal first, we are always going to be multiplying them. So we take our 18 times 3 in this case, which gives us 54. And now we have that third number left over that's going to be across from our variable. We are always going to be dividing by that number. So if I take 54 divided by my 27, I get 2. So in this case, z equals 2. So if you want to pause the video here and try that shortcut method for number 4. Alright, so this time we get our 12 and 2.05 are our two numbers diagonal from each other. Multiplying those, dividing by that extra number left over, I get 60. And that is going to be how we solve our proportions. So now let's talk about some word problems and how we're going to set up proportions to solve. So the first thing that we always need to remember is to stay consistent in our labeling. So remember that we always have two fractions that are equal to each other. If I have two different labels, so say money and hours, right? I always want one label to be on the top and one label to be on the bottom. So both of the money and money should go on top, the hours and hours should go on bottom. So that's what we mean by staying consistent with your labeling. So when we have a word problem, we're going to underline or highlight those numbers with the labels is key. We're going to fill in the labels in our proportion first, just like I just did with those money and hours. Then we are going to write our first fraction with the two things that are equivalent. So we're always going to have two different labels, and there's always going to be something that says this much money is going to give us, or this many hours gives us this much money, so on and so forth. So that is always going to turn into our first fraction. From there, we've already got our labels, so then we always have a third number that's going to be left over. We're going to use the labels to put that in its place, and then we are going to put the last spot, or the unknown, as our variable. And then we solve from there using the methods we just practiced. So that might seem like a lot, but once you actually see it in practice, I promise it's not that bad. Let's look at an example here. So we know that 1 inch is about 2.54 centimeters. How many inches are 20 centimeters? So you can see these highlighted numbers with their labels, right? 1 inch, 2.54 centimeters. How many inches? That's our unknown. That's going to be our variable. And 20 centimeters. So my two labels I have are my inches and my centimeters. And notice in those fractions how they have it set up. Inches and inches are on top, centimeters and centimeters are on bottom. I know that 1 inch is about 2.54 centimeters. So those are those two numbers that go together. That's always going to be my first fraction. So 1 inch is 2.54 centimeters. I know those are equal, so they get to go in a fraction together. My last number I have then is that 20 centimeters. So I have to figure out, do I put it on top with the inches or on bottom with the centimeters? Obviously you can see from this example, we put it on bottom with centimeters, which means that the how many inches, that x goes on top. From there, we just cross multiplied, just like we practiced previously in this video, and we got 7.9 inches. Let's go ahead and try some of these together. So number 5 up here, 10 raffle tickets cost $12. How many raffle tickets can you buy for $30? So I've got 10 raffle tickets. I've got how many raffle tickets? So we know that's going to be my variable x somewhere, right? And then I've got $12 and $30. So we've got those 3 numbers and my variable from the problem. I'm going to start with my proportion. I'm going to write my labels first. So I've got raffle tickets and I've got how much money they cost. Now I want the 2 numbers that are equivalent to each other to be that first fraction. I know 10 raffle tickets cost $12, so those go first. 10 tickets, $12. I've got 1 number left over, this $30. I know it's got to go on the bottom with dollars, and that means that that X for how many raffle tickets goes on top with tickets. Pause the video here and practice that solving to solve the proportion for X. All right, so we find those 2 numbers diagonal. 10 times 30 is 300. That leftover number gets divided, and so I know that for $30 I can buy 25 tickets. Let's try another one. Salad dressing is made with 1/2 cup of oil to 3 tablespoons of vinegar. How many tablespoons of vinegar are needed for 2 cups of oil? So again, I'm going to go back and highlight those keywords with their labels. So I've got 1/2 cup of oil and 2 cups of oil. I've got 3 tablespoons of vinegar. And how many tablespoons of vinegar? So I know that that how many is going to be my variable. All right, pause the video here and see if you can set up the proportion on your own. All right, how did we do? This one's a little tricky because it's got a fraction in it. It's okay to have a fraction in a proportion. It's just another number filling in its place, right? So we know that we've got oil and vinegar are our 2 different labels, so I've got those first. I know that 1/2 cup of oil is equivalent to that 3 tablespoons, so that 1/2 and 3 go together in my first fraction. My third number left over is 2 cups of oil, which has to go on top with the other oil, leaving my how many tablespoons variable to go on the bottom there. Pause one more time and try to solve this one. All right, so we did our 2 times 3 gave us 6, divided by our leftover 1/2 gives us 12 tablespoons of vinegar for 2 cups of oil. All right, next one. A manual reads 10 pages in 6 minutes. Which proportion can be used to find out how many total pages he can read in 24 minutes? So we have a bunch of different options here of which one could be used to solve this problem, right? So which proportion could be used? This is how I have my students do this. We know how to set up a problem and we know how to solve a proportion based on that. So what I tell my students is ignore these answers for now, solve this problem the normal way that you would in your way, right? So it makes sense in your head, and then go back and figure out which answer matches yours. So we're going to use the same methods we've been doing. We're going to highlight those keywords, 10 pages, and how many pages. We've got 6 minutes. And 24 minutes. So I'm going to start with that second part actually down here first. So I've got my pages and my minutes. I know that 10 pages is equivalent to 6 minutes, so those have to go together for that first fraction. My third number left over is that 24. 24 minutes goes on bottom, leaving my variable for how many pages on top. So now I'm going to solve, right? So we're going to take that 10 times 24. Gives me 240, and I'm going to take my 240 divided by 6 is going to give me 40 pages. So I've got my answer. Now, how do I take that answer and match it up to one of those proportions? So the first thing we can look for is we multiplied 10 times 24, right, and then divided by 6. So if I were going to go and do this butterfly method for A, I know I'd be doing 10 times 6 divided by 24. That's not going to give me the same answer. B, 6 times 10 divided by 24, not what we did. 10 times 24 divided by 6, yes, this is what we did. Just checking the last one, 6 times 24 divided by 10, that's not going to work. So our answer here is C. And they did set it up exactly like we did, right? 10 over 6 and x over 24. But even if those were flip-flopped, like x over 24 and 10 over 6 or however, as long as I'm doing that same multiplication and dividing by the same number, and I would get that same answer when I do my butterfly method or cross multiplication, that is going to be the answer that matches up. So this is how I have my students do these problems. Do it yourself first, right? Just like you normally would, and then go back and see which proportion matches. Okay, so that is how we solve our word problems using proportions. The last part of this video is going to do specific conversions. So we're converting between two different units. We're going to do this exactly the same way that we just did our word problems. It's just a more specific type of problem. So for number 8, we have a desk is 58 inches wide. 1 centimeter is approximately 0.4 inches, or 0.4 of an inch. What is the width of the desk in centimeters? So same exact steps, we want to find those labels first. So we've got 58 inches and 0.4 of an inch. We've got 1 centimeter. And what is the width in centimeters? All right, so let's go ahead and start off with our proportion. We know our two labels in this one are inches and centimeters. Here's where we have to be careful. So far, pretty much every problem has been those first two numbers, right? It says this is equal to this, how much is this, right? But be careful with this one. They start off with a desk is 58 inches wide, but they don't tell us what that's equivalent to. That's actually what they're asking in the question. What they do tell us is that 1 centimeter is approximately 0.4 inches. So those are the two numbers that are equivalent, and those are the two numbers that need to go in that first fraction. So it's not always the first two numbers, it's always the two that are equal to each other. So I'm going to fill out that 1 centimeter and 0.4 inches. The third number that I have is 58 inches. So that's going to go on top, and I'm going to put that missing variable, how many centimeters is our width, as our x on the bottom. Pause the video here and try this proportion on your own. All right, so hopefully we did the same thing. You're multiplying your 1 times 58, dividing by that leftover 0.4, and we get 145 centimeters. All right, we've had lots of practice, so I'm going to pause the video here, and I want you guys to solve number 9 completely on your own. Okay, so we have 1 liter is about 2.1 pints. How many pints are in a 5-liter jug of juice? So again, I've got my liters, pints. I set up my proportion. I put my labels first, liters on top, pints on bottom. Just for me, you could have flip-flopped them. That's fine as long as you're staying consistent. Then we know that 1 liter is about 2.1 pints. Those have to go together for that first proportion or that first fraction, 1 liter and 2.1 pints. Then I have that missing number 3 is a liter, so it goes on top, leaving our variable on the bottom with how many pints. We multiply 2.1 times 5, divide by 1, and we get 10.5 pints. All right, last but not least, here's our last problem that we see. We're bringing back the ratio tables from our previous lesson, along with our word problems, and we're going to see if we can solve this problem. So, Miss Durham kept track of her summer road trips in the table below. How many miles could she expect to go using 10 gallons of gas? So we've got all these different equivalencies, right? 3 gallons of gas was 84, 7 is 196, 12 is 336. But what we need to know is how many miles, right? That's going to be our variable because that's what the question's asking. Can she go on our 10 gallons of gas? So we need to use that 10 gallons in our proportion. So let's go ahead and start our proportion. Again, we've got miles and gallons. And actually, I'm going to flip that around because of how the table is set up, just to be a little less confusing. So the table has those gallons on top and miles on the bottom. All right, so I can use for my first fraction, we're always looking for those two things that are equivalent to each other. I can use any one of these fractions. So I could start with 3 over 84, 7 over 196, 12 over 336. It does not matter which one you use as long as you are lining up those labels just like we practiced before. So I'm going to use the 3 gallons of gas took her 84 miles, so I know that that is true. And now I'm going to go back to that 10 gallons of gas, right, that we know from the problem. So 10 is going to go on top with my gallons, and my how many miles, that variable is going to go at the bottom. Now I'm going to solve this just like I've been doing with everything else. So I have 84 times 10 gives me 840, and 840 divided by 3 gives me 280 miles that she could expect to go on those 10 gallons of gas. That's kind of putting everything together. All right, so how are we feeling? We've talked about how to solve a proportion. We talked about how to take a word problem, turn it into a proportion and solve it. And we've talked about how to convert between different units using proportion. So hopefully you've learned some fun strategies that can help you out a little bit. Hopefully we're feeling a little bit more confident. I hope you have a great day, and I will see you next time. Bye.